are called congruency conjectures. You don't have to memorize that. What you need to know is if somebody asks you, say on a test or a quiz, to prove something is congruent, your final conclusion is going to be one of these 5 things. Or, if nothing of these, not congruent. This is not similarity. Similarities where they're alike, but it's kind of been shrunk or enlarged, like on a copy machine, to scale. Congruency means exactly the same. Exactly the same. Okay? Okay, so under that, I want you to copy this example, please, and make sure you have all of the markings on there and all of the letters correct. So under where you wrote G4, copy this example, please. Make sure you've got all of your letters correct and all of your markings. Quietly. Up at the top, say, use a 2-column proof to show that triangle ACD is congruent to triangle BCD. How do I start? If I'm using a 2-column proof, what does it look like? A T-chart, okay? Even if you didn't know what it was called, but somewhere on your paper you started to do something like this, great. Anybody remember what goes on the left? Statements. On the right, justification. Even if on the test, state test, work sample, or otherwise, you don't remember statements and justification, still set up your proof this way. Even if you don't remember what words go here, it's a much more thorough, logical kind of setting up of your ideas. Okay, how many statements should I aim for? 3. Now, somebody raise your hand and tell me, why 3? Why do I pick that random number? It's not really random. Travar? 3 sides in a triangle is a decent answer. Yeah, but it's more than that. It goes back to this. This is one of my answers, right? What does 3 have to do with these things? Most of them have 3 letters, right? Except for hypotenuse leg, which is a little bit different, and you're not very often going to get a right triangle. So because these have 3 letters, I'm aiming for 3 things, okay? But Trabar's right, some of that has to do with it being a triangle. Okay, somebody from the diagram, pick something that I could write as a statement here. Moises? Line AC is congruent to line CB. He said it perfectly. You have to symbolically write line AC is congruent to line CB. So those bars over AC and CB have to be there. And Moises, what would be your justification? Given. Yao, something else? Line CD is congruent to line CD, and my justification is reflexive. Don't write given. That's not right. It's not given. It's not marked. So many students were missing this the last time, that word reflexive. All right, Colleen, finish us up. D, C, B. Excellent. And my justification? Given. So, some of you had trouble the last time you were working on proofs because you finished here. You were like, great, look at my T-chart. Woohoo, 3 things. Done. Not done. This is not finished. And I wrote this in giant red pen. This is one of your answers. You got to come up with one of these. Notice none of them spell a cuss word, okay? So you have to write some kind of conclusion down here. What is it? Say it. Side angle, side congruent. Questions about anything I wrote there? Questions about how I knew it was given? How we knew it was reflexive?
How come? I mean, I understand why it's like this in this problem, but in another problem that you did, it was a little confusing. Was the difference between side angle and side angle side?
Well, side angle doesn't exist because that's ass spelled backwards. So if you're talking about, so for example, if you come up with something and you're looking at it's this possibility or this possibility, these don't exist. So if you think that the angle is only touching one side, right, it's not in between. So on this diagram, when you look at that diagram, the angle is touching both of those sides, right? The side here and side here. So that's why our angle goes in the middle. But if you think this is the order, then you just write not congruent, because that's not a possible answer. Good question. Anybody else? Okay, great. Copy this diagram, please, including all the letters. And then I want you to do a 2-column proof for these. Parallel. Arrows mean parallel, not equal. So if you chuckleheads wrote AB is equal to DC, no. And then you wrote AD is equal to BC, double come on now. That's parallel.
Is it reflexive?
No, they're not reflexive. That's not even the definition of reflexive.
Wait, no, side DB to BD.
That's not what he's talking about. That is reflexive.
Yeah, I did it.
Stop yelling. When they give you parallel lines, you have to have angles. Go back. You got 2 minutes. Yolanda, turn around, please. When they give you parallel lines, you have to have angles. Go back. You got 2 minutes. Okay, on your proof. First of all, if you were one of the many that thought that arrowheads meant equal, please make some kind of note that this is parallel, not equal. Because you'll be the first one to make that mistake over and over and over again. And guess what I'm putting on the test? Statement 1. Somebody tell me something that is true. Well, hang on. I'm going to start this way because we already said this one out loud. DB is side DB is congruent to side DB, and that would be reflexive. When it's written on top of itself, that's reflexive. Stop talking. So now you've got to come up with some angles. Jose, you can tell me something good?
Side.
Nope. Charlie, got it? Angle ABC, so that would be here. Just close the door, because obviously you can't control yourself. Is congruent to BDC. And Charlie, what would be my justification? You are on fire with alternate interiors today. Nice. Okay? That leaves one more statement to conclude. Quinn, do you think you can finish us up then?
I don't think so.
Okay. Anybody else think they can name that last set of angles? Hunter?
Is it ADB
ADB.
and
No. This one here. DBC. Is that what you said? I'm sorry. I thought you started with BDC. I'm sorry. D as in dog, B as in boy, C. And then our reason would be the same. Alternate interiors. Alternate interiors, alternate interiors.
I have a question.
Yeah.
If it's a parallelogram though, like, because it is, if it's a parallelogram, knowing that, don't they have to have two pairs of equal sides?
Yes. So you could say over here, if you wrote DC is equal to AB, your justification could be definition of a parallelogram.
Okay.
But you would have to write that in your justification. Okay, last one together. Here we go. PQRS is a rhombus. Prove that triangle PQT is congruent to triangle STR.